Clapping for? Oh, it's going.
On me.
All right.
I need to go.
No, I was. Tired.
You take
I
I feel like our study hall should be a regular class.
agree. I had one in college. We had a homeroom. We might do that next year. They're talking about doing a homeroom. Maybe not. All right. I think 1 through 6 is the toughest, in my opinion. Yes.
Hold up.
Hold up.
Wait a minute. Isn't that sorry? That's what it is.
I got a pump shit out to go to on the south side. So I'm ready to get shot.
Let's see what we need. All right, before we do 1 through 6, let's talk about what it even is. Newton's laws was ages ago, but I reckon you'll remember some of it at least.
So, an object in motion is based on motion and motion.
Can I write this on the
A
back?
plus.
You know what?
That's
Can I
the
write
most
this on the
common.
back?
That's the most common.
Yes.
Everybody remembers.
So when a parent gets sit next to Altair during the test?
Nah, cause
An object.
Because that's not on the test.
Oh, wow.
Capital F.
Cheat sheet.
Capital F stands for force. So what do you think FG is?
Force of gravity.
Force of gravity. It's the weight, also known as force of gravity. So we'll say, well, let's just write that. Force of gravity or the weight. What number do we assign to lowercase g? 9.8 meters per second squared. Positive 9.8 meters per second squared. I'm not sure if this will come up, but I'm just going to write it in case it does. If something is falling, so in free fall, sometimes you'll calculate like the time it takes to fall, or you'll calculate the air resistance, yeah, stuff like that. If something is falling freely, there's no air resistance, we use negative 9.8 for some values. So if I use negative 9.8 later on, it's because it's the letter A in that particular equation. This one doesn't always come up. You don't always use negative 9.8 when you see the letter A. But if you see the letter G, you always use positive 9.8. Sometimes when you see letter A, negative 9.8 comes in, but not sure if we'll see that.
So that's not gravity then, right? Like that don't have nothing to do with gravity.
Not really. Kinda, sorta. But I'm just putting that up there just in case it comes up. I don't believe it does. Let's see what else we have. There's a couple of other forces. This one. So FG was force of gravity. What do you think FF is?
Force of friction.
Force of friction, or frictional force. I'll just say force of friction. There is no special equation for this thing. It's just good to know it. We might be able to get away with that for now. Nah, we'll throw all of them down here. Anybody remember what FA is? It's not Fa.
Applied force.
Applied force. This is when like someone pulls on something with a rope, or if they lift it with their hand, or they push it sideways,
Or you pull it.
or pull it. Applied force. What else we got? There's one more off the top of my head. FN.
Normal force.
Normal force. This is the force that keeps us from falling through our chair. So normal force pushes up off of the table. On this final exam, normal force will always push up. If you take a future physics class, that's not true, so don't tell your physics teacher I said that. But that's the idea. I'm standing here on the ground. Gravity's pulling down, but normal force is pushing up, and it's battling gravity. I think we can get away with those. Yeah, let's do this. Okay. Now, a lot more to know as we solve the problems, but let's take them one at a time. Again, 1 through 6, in my opinion, are the toughest. Here we have a right-facing 68 Newton force is applied to a 12 kilogram block that, as a result, accelerates at a rate of 4.5 meters per second squared. Calculate the frictional force that opposes the motion of the block. For number 1, we're using the 3 steps, so to speak. So we have to draw all the forces. Maybe I'll make a list for you for the test. I think that's probably what we'll do so you can remember the 3 steps. So the 3 steps are, 1, label all the forces. So, for example, what direction is gravity?
Upward.
Down. Fg. Which force, if like, let's see, what is this? A block. A block is sliding across a table. What's the force that keeps it from falling through the table again? Normal force. That's pushing up. Okay. What do you think? Yeah. What direction is applied force?
Right.
Right.
But how do you know that?
Because they say, yeah, a right-facing force is applied. And if they said, I don't know, your cousin is pushing something to the right, we know that's an applied force because he's directly touching it with his hand or her hand. And if I'm sliding right, friction. Very good. Friction is left. We might not use all of those.
Quick question.
Yeah.
So if there's an applied force, is there always going to be a friction?
Unless it says no friction.
Right. So I'll tell you now, this is the exact drawing that you'll have to use on the final exam. Maybe I should check that. It might be pushed left. You know what? I will check just so you can memorize if you want to.
Thank you so much,
Oh, he's the
sir.
best.
Goodbye.
Yeah, that's the exact picture. So we have something pushed to the right, and all the other 3 forces will still be there. It's not a frictionless surface. So that's step 1 in the 3 steps. Step 2 is to label your net force equations. And this is hard to explain, it's easier to show. So this is sigma Fx. It means the sum of the horizontal forces, and that means it's Fa minus Ff. This equation will not be given to you. I made that equation up just now based on my picture. So I'll give you all the equations you need except for this, except for these net force equations. You have to write those based on your picture. So based on that, does anyone know what our y equation will be? Fn minus Fg, because Fn is up, Fg is down. That means Fg is negative since it's pointing down. So there's step 2 in the 3 steps. And step 3, I wonder if, I think the next page will be, yeah, I want to use the darker screen so that it shows up on the video. So the next step is to plug in any mini equations that we know. I think I'll just write them off to the side here. So there will be a little side note on your equation sheet that says mini equations. For example, Fg equals mg, that was up there. Sum of Fx equals max, these are given to you. And sum of Fy equals may. Step 3 is to plug in any of those that can be plugged in. For example, sigma Fx max, right there, max. We plug in max for sigma Fx. So it's max equals Fa minus Ff. If you're a whiz kid, if you're a good problem solver, you know that you don't even need to set up the next one, but maybe you don't know that, so we'll just go through it anyway. May equals Fn minus mg. Now we're done with all the 3 steps. Wait, where did mg come from?
The FG equals MG.
G equals mg. It's one of those equations up there. So here's the deal. This equation over here is not actually useful to us. These guys, basically this is 0. This whole thing is 0. The whole left side is 0. That means the whole right side is 0. We're not going to use it for anything. The whole right side is 0 because there's no vertical acceleration. We're just going sideways. Main thing, I guess we can phrase it this way. Read the problem again. What direction is it accelerating in? Based on the way it's written. To the right. It's accelerating horizontally, so we're calculating the horizontal acceleration. That's what x means. It means horizontal. What does y mean? Vertical. Yeah.
No, I was gonna say, it says Fn minus mg. That is only
Well, we replaced this fg with mg because it's one of those minis, but we don't need that equation anyway. Now we can plug everything in. I think they gave us mass. 12. Okay. So it's 12 times 8x. I don't like the way I did that, but that's fine. Equals 68. Oh, we're calculating friction. Not bad. Yeah, 12 times 4.5 equals 68 minus FF. What would you do first to solve? There's many ways to do it. 12 times 4.5, good way to go. Clean things up a bit. It's 54. 54 equals 68 minus FF. Subtract 68. So if we subtract 68, by the way, of course, if you can't see from where you are, you can come on up. There's some space up here with all those seniors gone. It's our school now. Negative 14 equals negative FF. Don't miss that negative.
Divide by -1.
5 by -1 and we're done, son. 14 newtons. Woo! That's a tough problem. But if you want to get an A on this final exam, all you got to do is, take out a fresh piece of paper at home, do the problem again. I guarantee if you try this problem again, even though you're using the same numbers, it's good practice. Number 2 is pretty much the same thing. So if you understand those two problems, if you can do them from memory, you're going to get 100% on that problem on the test. And I want you to get 100%. It's easier to grade. So I just do a check mark and I move on. Questions here? Cool. I think I will stay on this. Page, sit back around Phil.
You figured it out.
Yeah, I just didn't want to. I was just lazy. I didn't want to do it. Okay. So what number would be on there then? 3?
Yeah.
Not exactly flying. So number 3 is just like the one on the final, where something is going to be lifted up. Well, it might not be moving up. It'll either be moving up or down, but either way, there's a force pulling up, and it's either rising or falling. So like an elevator or a bucket, those are the classic ones. So number 3, a 78 Newton force pulls up on a 6 kilogram bucket of water. Calculate the acceleration of the bucket. This one's a little easier because there are only 2 forces. So I don't think we need to, let's write it anyway. I don't know why I like writing the weight in the box, the mass in the box. Okay. There's no friction, there's no normal force, because it's not on a table, it's not sliding. What do we have though? Gravity and applied force. I heard a couple people say each one. So yeah, gravity's down, applied force is up. So someone is pulling up on the bucket. There's no gravity pulling up on the bucket, so it's got to be applied force. Yeah.
Okay, so on the test, I remember one where she was doing, it was said tension instead of applied force. Would it be like that on the test too?
Yeah, tension is the same. For this class, tension is the same. Whoops.
Same.
I'm like, keep going too fast. Same as applied force. So if they tell you the tension, that's actually the applied force.
Okay.
Okay. If I write my net force x equation, do you see a problem if I try to write my horizontal equation?
Yeah.
Yes.
But then-
There's nothing there. So we can write it like this, that's the true answer, or we can just save some space. Like why even write it? I don't care about that. Let's look at the Fy equation. Fy equals, what is it? Fa minus Fg. And again, I will not provide that on the test. You have to write that based on your picture. So this is a tough problem because you have to draw the picture correctly and you have to write the equation based on your picture. There will be a problem on the test that has this exact same picture with that exact same equation, and we'll plug in the minis. So we can go over to our mini equation list. Can I replace Fy with anything? My. The other one was Fa. Is there anything on here that I can replace Fa with? No, not really. What about Fg? Mg at the top. So Mg will go in for Fg on the other page, and Ay will go in for Fy on the other page. So here's our rewrite. May equals Fa minus Mg. Okay, let's plug in our stuff. What are we trying to calculate again? Acceleration, so that'll have to stay. 6 times Ay equals 78 minus 6 times 9.8. And from here, your algebra skills will be necessary. On the right-hand side, we could just type that straight into our calculator. 19.2? Sounds good to me. And we'll divide. We got an answer. 3.2 meters per second squared. I think the first one's tougher. No, there's just a lot of extra info. We might not get well, questions there? That's tough stuff, man. Number 5. So far we've gone over 2 things that'll be on the test. This is our third, and on the test it's pretty much exactly the same again. It's the same as this one. This one in particular, this applies a lot of your skills, so try to keep it, I don't want to surprise you on the test. Oh, I just want you to show me that you know how to do this stuff, that you know how to use this skill. So it's going to use geometry skills and algebra skills. Here's what we have. A force of 170 is applied to a block and is directed at an angle of 26 degrees above the horizontal axis. As a result, the block slides horizontally across the frictionless surface. Calculate the acceleration of the block if its mass is 4 kilograms. So we know 4 kilograms. We know that this F right here, I think 170. What direction is this thing going to slide? Is it going to jump straight up or slide sideways? Sideways. So here's the important thing. We need to know this amount of force right here. Like, if you went through your 4 steps, you'd do a bunch of extra stuff you don't have to. Like, there's normal force, there's gravity, but those aren't doing anything. Those aren't actually causing sideways motion. We don't care about those. So you could do it, but it'd be a little bit of a waste. What we really care about is this side right here. And we have a triangle set up. We're going to have to use our geo skills.
Cosine.
Let's see, cosine? Anyone else say cosine?
Wait, yeah.
Here, I'm going to draw the triangle larger. I always like to do that. You don't have to do this. I actually, if you don't know why I'm doing it, I wouldn't recommend it. So 170, we need this right here. We call that, I hear my students say this to each other all the time. I guess they just like physics. They say facts. That means applied force in the x direction. But you can just call it whatever you want, fx,
I
whatever.
think a fax machine, like, gives you messages.
Yeah. Okay, so here's our angle. I know this is the hypotenuse because it's the biggest one. What is this one called? Adjacent or opposite?
Adjacent.
Adjacent, because it's right next to the angle. It's adjacent to the angle. This is opposite to the angle because it's way over on the other side. Long story short, if you see this block here, you're going to use this. F cosine theta. I think I feel like I should go check the equation sheet too. Let me BRB.
BRB.
That funny.
Cold.
I'm so tired.
Oh, yeah.
God.
This is an equation that's given on the equation sheet. It says fx equals f cosine theta. So we can use that right here. Do you remember what we can replace fx with? Max. And that'll be on the equation sheet too, under our mini equations. So we're ready to solve it. Max equals f cosine theta. Hey, if you didn't understand what we were talking about here, don't worry about it. When you see a block pulled at an angle, you can use that. You might be a little blind from there. You might be a little stuck. It'll be tougher if you don't understand the process up there. You'll still be able to make it through. Let's see what we have then. So it's 4 times ax equals 170 cosine 26. Mr. McGuire, should we be in degrees or radians?
Degrees.
Degrees. The number's in degrees, dude. Of course you want to use degrees. So 4ax on the left, we type 170 cosine 26 in our calc.
152.79.
Cool. I'm just gonna go 153. 152.79 is fine. As long as you use 3 or more sig figs, you're gonna be okay. So, looks like the numbers I picked were a little strange because this is a big acceleration. This is some rocket science level acceleration. Anything around 38 would be solid. If you're getting like 30, 31, that's a little too far off. Man. So that's the tough stuff. Yeah, we're kind of starting from the toughest and going to the easiest. So I think Monday will be easier. Hope so. I'm already exhausted. Anyone still looking at that one? I can go back if you need me to. Yeah, you're still looking?
Yeah.
Alright, since I'm on my tippy toes.
Yeah.
Yeah, when's our final? Our finals Wednesday? Yeah. Wednesday is 0127. And 3, 4, 5, 6 is Thursday. And then Friday's nothing.
Next should go this fast.
It should be, so we don't get snow days, snow days.
We leave early anyway.
That's what I'm saying, that's what I'm. You know, prom maybe May 8th.
Why?
We're still gonna be in school. Martin said that's like the only weekend we can do English. So like that Friday, we have to come to school. Far more.
So that Saturday is on there?
It's May 8th or whatever that weekend.
Don't be prepped.
Like, then you have all of, Saturday morning, like, no.
Oh, yeah, this one get good.
Oh, yeah, so this is right here.
Conservation of energy.
Hold up, man. I'm breaking my own rules here.
Extra credit, I think.
No food.
Yeah, I don't think I'm gonna have that rule next year.
What?
I was also gonna have the rule no junk food, but here I am eating combos.
It's okay, Mr. Byron, we're on those.
I'm sneaky. Nobody put it in.
Oh.
He said tacos, I was like, what?
Never took her.
This is a pretty this is a tough equation to use.
My dad, low key though. He says don't touch.
So I'm giving you that, but you still have to know all the other letters. So like M is easy, you guys know that already. It's mass. 2 kilograms. G, we just talked about it. It's just going to be plus 9.8. We don't really need to talk about the meaning for this final. I don't even need that plus sign, but I mean, why? Leave it out. Story. H is height. Spoiler alert, I'm going to give you the height in feet on the test
Why you put them?
because that's the standard unit, meters. So if I give that to you in feet, you have to convert it to meters.
Oh, wow.
So, okay, so if H is height, what's HF? Homewood Flossmoor? No, what's it really?
Height, final height.
Final height, HO?
Initial height.
Inertial height. Okay. So, although so that cuts the letters down a little bit if you know what those subscripts mean. The only other one up here, so there's really only 4 letters. The only other one up here is velocity. We've been using that since last year, 2019, 2018.
Wow.
So if that's velocity, what's VF?
Final.
Final velocity. I think that's enough to get started. We will have to come back to it. I'll probably write some other stuff over here. So if you've got a nice spot for 2 extra equations, I'd keep the space there. Let's just try number whatever, 7? I don't know. We'll get through all this. Whatever. I'm stressed out, man. I thought this would go a lot faster. Okay, here we go. A 12 kilogram hammer. 12 kilogram hammer is dropped from a height of 2. Use the conservation of energy to calculate velocity of the hammer as it hits the ground. So here's how you get, like, honestly, I'd probably give you 3 out of 8 points if you did just this. If you wrote down the conservation of energy, you're showing me that you know that this is called the conservation of energy. That's the whole point of the problem. I want you to know that energy is conserved. It never goes anywhere. So if you waste a bunch of energy at home, if you keep the lights on all night, you'll just tell your parents, no, I'm heating the house as well because it changes from light into heat energy. You're welcome, Dad. But I wouldn't do that. Okay. So, if they say use the conservation of energy, which they're going to do on all 3 of these problems, you start with that. Now we can plug in everything else so that they tell us. I mean, it's going to be tricky, but let's see what they gave us. 7. Okay. 12 kilogram hammer, it's dropped from a height of 2. So where's that 2 going to go?
And
Initial height, and 12, 9.8. What about the initial velocity if it's dropped? 0. Since it's dropped, initial velocity is 0. This whole thing goes away. It falls and it reaches the ground. What's the final height if it falls to the ground? 0. So there's going to be a problem like this where something's going to drop to the ground. And from that, if something drops, you should know that the initial velocity is 0 and the final height is 0. So we'll bring that down to the next line.
When can you cancel out the m's? Can you cancel out the m's in this case because it's the same mass?
Yes. There's only one case where you can't, and we'll do that one last. So, yeah, for now, let's just say cancel out the m's. So we'll be able to cancel out these m's. We divide both sides by m. And you don't have to show the algebra, but some people might be staring at me like, what? Divide both sides by m? I'll show. So m's cancel. Here's what we're left with. G h initial equals v 1/2 v final squared. So that's a little sloppy. G h initial equals 1/2 v final squared. Let's see what we didn't even figure out what we're trying to calculate yet. Velocity.
Yeah.
Velocity final. G is 9.8. Initial height was 2 because it's dropped from a height of 2. Equals 1/2 v final squared. So at this point, if you just wrote down like a random answer, if you didn't know how to solve that and you just wrote 7, you'd get 6 out of 8 points because you haven't done the algebra yet. But that's pretty much what I want you to do. Cancel stuff out. That's the whole problem. The rest of it's just algebra, which you guys already took. 19.6 equals 1/2 bf squared. What now? Multiply by 2. I think that's 39.2.
Yeah.
Last step, you square root. When you square root, you're supposed to put that plus or minus, as your math teacher taught you, and you choose which of those you like. I think it's 6.26. I don't remember. So we got to choose when we do a square root. Is the hammer moving in the positive direction or the negative? Negative. That's only 1 point though. The whole problem is 8, but that last negative sign there, it's only 1. It's okay if you
But
forget.
then how to find one?
Final will have 12.
12 questions.
Final has 12. So this is twice as long. You've got 2 problems to practice for each one. For example, 7 and 8 are pretty much the same problem. It's something being dropped. And there's one problem on the test that's just like that. It's being dropped.
Why is the answer negative again?
Since the hammer is going down.
Down.
My stuff froze up. Hope it didn't stop. Cool. I think we'll do one more and we might call it. Maybe we'll vote. I don't know. We do democracy. Monday's going to be a lot easier, I think, because this is all the stuff we saw months and months ago. All right, 9. 9 says, it's very poorly typed, but that's okay. A 1,400 kilogram coaster is moving with a velocity of 5.7 when it is at point A, 140 meters. Let's look over at the picture. What is 140 labeling? What thing is it labeling? Height. It's labeling height.
Oh,
Let's
the
keep
initial
reading
height,
this.
right?
Probably the initial. It says,
It's
what would be the car's velocity at point B when it's 95 meters high? Usually roller coasters start with a big drop. So yeah, final height will be 95, initial height will be 140, and we're trying to get the car's velocity. Again, it's poorly typed there. It says, it's supposed to say, use the conservation of energy to solve. So let's get our 3 points. M, G, H initial plus 1/2 M, V initial squared equals M, G, H final plus 1/2 M, V final squared. That's written on your equation sheet. You don't have to memorize that.
Oh,
Just gotta
it's
find the
not-
one long scary equation. That's the one. Yep.
Okay, so it has it has 3 heights. So wouldn't the one by the end of the roller coaster be the final height?
Point B would be mine.
They're kind of ignoring the rest of the coaster. They're just saying like they want the velocity at point B, and that's where the problem ends. This is another case where we can cancel these M's. You know, I think we should do all the way up to 11. Just get it out of the way, and the next week will be easier. Okay, M's cancel. I wish something else did, but I don't believe that's the case. No, we don't know anything else. So we'll plug everything in from here. I think they're trying to get final velocity from us here. Yeah, they gave us initial height and initial velocity. They gave us final height, but we need to find final velocity. What's G? 9.8 times, what was that initial height?
140.
140
It can't,
plus 1/2.
can't that cancel out because of the initial velocity 0?
I don't think initial velocity is 0.
Isn't it 5.7?
Yeah, 5.7. Very slow at the beginning. Isn't that weird? It gets so quiet. I feel like there's a ghost in here. Not about ghosts. 9.8 times 95 plus 1/2 BF squared. Maybe you can see the difference between this problem and the former problem is nothing really cancels out except the M's. So the algebra is tougher. Maybe not though. We could type this in our calculator and it'll spit out a single number. So that's probably your best first step. I don't remember it. 1388?
Yeah.
Cool. 1388 equals, there's another one, 9.8 times 95. That sounds good to me, 931 plus 1/2 V final squared. And it's pretty easy from here. Clean it up, it looks better. Minus 931 on both sides.
457.
I got 457.
Oh,
What,
Nice
oh,
point,
oh,
next
oh, I
line.
thought it was 13.88. Oh, my bad.
Wait, hold on.
Yeah, that was my bad.
maybe it is.
98.
No, because
Oh yeah, those are big numbers.
I got 13 point. I got 13.8.2.
Oh,
Yeah.
yeah.
That's
My dad's one of them.
That's supposed to be 457, but it kind of looks like something else. Kind of messy. Multiply both sides by 2. This is the type of problem you're really going to have to check your answer on
Well, we can multiply by 2.
Get rid of that half.
to get rid of the half. And we square root both sides. It won't really matter on this one, but we should put a plus or minus. If you really wanted to know, the velocity would be plus. Your sign would be plus. But I wouldn't really care on this one. I only care about plus or minus with your velocity if it's moving up or down. So since this is moving directly to the right, technically it's plus, but it's about to go down, so it's tricky. We'd have to calculate an angle. So now, yeah. You know, I think I do have to show you the last one because it's the last energy problem. And then the tough stuff is behind us. I recommend doing those evens 2 through 12 over the weekend. If you don't manage to, we'll have a silent study hall on Tuesday, but you can ask me any questions on that day and check your answers as you go. So let's do this. Let's get this last one done. I think the easiest chapter for everybody was the electricity chapter, and that's what we'll review next week. So we just did it, so review's gonna be pretty easy. This is your focus. If you're gonna look over anything over the weekend, it'd be 2 through 12. The last one, 11. So here's where I go back to our notes that we took in the beginning. What we're going to do on this last problem is we're going to replace one of these mini equations with a variable. So we'll have EG, for example. I don't think we talked about this. Do you remember what EG is? Energy. It's a certain type. Potential energy. Why? What's the G though? Gravity. So yeah, EG is gravitational potential energy. We just call it potential energy. Yeah, I think I'm just going to call it that. Potential energy. Technically, it's gravitational potential energy measured in joules. I didn't mean to write it like that, but that's okay. EK, what's that one? Kinetic energy. And that's also measured in joules.
I forgot which one you like for the house.
Well, it's easier to figure out than you'd think. Like, anybody know why, like, which of these letters tells me that it's potential energy? Check out the G and the height also, but like, mainly like, that's a good way to remember. Here's G, there's G, so they're both potential energy. What is kinetic energy? If something has kinetic energy, what's it doing? It's moving. If something has kinetic energy, it's moving, which kind of brings us to this, velocity. Still, you don't really have to memorize that. I'm going to give you equations on the test like this. Like this. It'll say this. EG equals mgh, EK equals 1/2 mv squared. So one of those many equations will be replaced. Maybe two, but it's just one. All right, so let's do it. Let's look at this golf ball equation. Golf ball question. Golf is tough. I'm not a fan. Okay. A 47-gram golf ball is driven from the tee with an initial speed of 52 meters per second. Use the conservation of energy to calculate the kinetic energy of the ball when it reaches a height of 24.6 meters. Let's go over that again. So, look through that again. What are we going to calculate? Kinetic energy. It's going to be one of these. It's either, if we're calculating kinetic energy, we either need to replace this with EKF or this with EK initial. But while we're at it, let's get our 3 points. They said use conservation of energy. Let's get our 3 out of 8 points. Maybe we're out of time on our test. We'll just throw it down. mg h initial plus 1/2 m v initial squared equals mg h final plus 1/2 m v final squared. Okay, so let's talk about what we know. Just to save some time here, I'm going to tell you what's wrong with that mass. Yeah, we'd have to convert it, but let's not move too far from the discussion we're having about like using the equation. If you don't know that unit conversion, I'll show you on Tuesday. You can come on up and ask. We basically divide by 1,000. Okay. Let's talk about the first spot. Do we know the initial height? Like, where does the golf ball start? Well, we're like descriptively, not in terms of like numbers, like where does it start?
On the tee.
On the tee, which is pretty much the ground.
So what is
So if you said, it'll just be 0. So since H initial, it starts on the ground, H initial is 0. So do we know the speed it leaves the tee with? 52. So that's going right here. Based on that, we know they're trying to get us to calculate this. This will be EKF. Because that's going to be 52. G is 9.8, and HF is 24.6, or whatever that number was. So we want to find the kinetic energy later in the problem. That's why it's a final.
Did we not cancel out the answers?
In this case, we can't cancel out the M's because of the E, the capital E. So if you're asked for energy or you're given energy, you can't replace the M's. I'm gonna write that in real quick. If you're asked for energy, either types, it could be kinetic or potential. If you're asked for energy or given energy, you can't cancel the M's. Something that might happen is they might say, final kinetic energy is 40 joules. If they said final kinetic energy is 40 joules, we would take this whole thing right here and we would just write 40. But we're not going to do that on this problem because they didn't tell us that. I'm making that up. So let's see what we can solve from here. Now, MGH initial is gone, so we're already at 1/2. 1/2 times 0.047 squared. Wait, that's not right. 1/2 times M times V squared. So that's 1/2 times 0.047 times 52 squared equals
63.54.
maybe. I want to plug it on first though. That's 24.6. So right there, that's our, I'm not really done writing it, but I ran out of space. The algebra here is going to be a little easier than the other ones, fortunately. Plus EKF. So the nice thing is that we'll type those terms into our calculator. We'll get a number here, get a number here, and then we'll just subtract. So what'd you get on the left there, Chris?
63.5.
That sounds right. 63. I'm just going to round to, wait, no. Anyone else get 63.5?
Yeah.
Okay. Just, I don't, doesn't sound familiar. 63.5 equals, is that like 14 or something? Okay, 11.3. And then we subtract 11.3 on both sides.
52.2.
Cool. Bam. That's a tough problem. It's that middle step right there that I'm testing you on. Can you replace things? Can you replace with EKF? All right, so 2 through 12, those are on you, man. You know what to do. I'd try them this weekend because they're the toughest half. If you do maybe an hour of studying on Sunday, maybe you'll be good until the next day. Woo! Should have broke that up. It's all right. What's I left the video going.